Multiplication of algebraic expressions. For this, we have to know the laws of exponents, which are used to multiply the literal quotients of the polynomials. The law is that x power m into x power n is equal to x power n plus n. In algebraic expressions, we have so many things like monomials, binomials, trinomials. So we'll see how to multiply the monomials first. Monomial is an algebraic expression with only one term. Here we have two monomials, 6x is one monomial and minus 2xy is another monomial. For this, we have to multiply the numerical quotient first, that is 6 into minus 2, which is minus 12. After that, we will multiply the literal quotients x from first monomial into x from the second one. So here for x, the power would be 1. As per the law of exponent x power m into x power n is equal to x power m plus n. Now here in place of m we have 1 and in place of n we have 1. So it would be x power 1 plus 1, which is x square. Write it down here, x square. With that, the first monomial is done. But from the second monomial, we have y here. We will write it down as it is. So like this, we have to perform the multiplication of monomials. Multiply the numerical quotients and the variable quotients that are common in both the monomials using the law of exponents. If there is any variable that is not common in both the monomials, we will just write it down as it is. Let us consider another example, 5xy into 10x cube. For this, first thing is to multiply the numerical quotients. We have 5 and 10. 5 into 10 is 50. And the next thing is x. X from first monomial should be multiplied with x cube from the second monomial. Here x means x power 1 into x cube. It should be equal to x power 1 plus 3, that is x power 4. So we'll write down x power 4. After that, we have y from the first monomial. It is not there in the second one, so we will write it down as it is. Now that we understand how to do multiplication of two monomials, next one is multiplication of a monomial by binomial. Here again we have two polynomials. The first one is monomial with a single term, whereas binomial is a polynomial with two terms. Monomial has to be multiplied with each and every term from the binomial. First, we will write it down like 2xy into 2x. This is with the first term plus this sign plus we have to write it down as it is. Braces open, monomial 2xy into the second term from binomial, that is 3. So now it is nothing but multiplication of two monomials here plus multiplication of two monomials. We just looked into how to do this multiplication. So first multiply the numerical quotients, 2 into 2, that is 4, x into x. So again x into x is nothing but x power 1 into x power 1. For that we will have x power 1 plus 1, that is x square. Here we will write down x square. The remaining literal quotient is y here. Plus, this plus comes as it is. Here again we have a constant term. So just multiply the numerical values. 2 into 3 is 6 and xy as this. This is how we multiply a monomial with a binomial, and this way of doing is called horizontal method. But the multiplication can also be done using a vertical method. We'll see how to do in vertical method now. Say there is a binomial 4x minus 5y square. We have two terms, so it is a binomial into a monomial, that is 3x cube. First, we will multiply these two terms, that is minus 5y square into 3x square. Multiply the numerical quotients. Minus 5 into 3 is minus 15. We have x cube here. So we will write it down as this x cube. And this y square, we'll write it down as this y square. Now after doing this, we have to multiply the next term. That is 3x cube into 4x. For that, the first two numericals are 4 into 3, that is 12. X into x cube. Add the parts. So for x it is 1. So 1 plus 3 is 4. Using vertical method, we do multiplication like this. Each and every term we have to multiply with this monomial. Multiplication of binomial by binomials. Here, to do this, each and every term from a binomial has to be multiplied with each and every term of the another binomial. Like say we have a plus b as one binomial and c plus d is the second binomial. First with a, we have to multiply this entire thing. That is the second binomial c plus d plus b into again the second binomial c plus d. This is now like monomial into binomial which we have seen. So AC plus AD. Now this is also monomial into binomial BC plus BD. This is a process we will follow to multiply two binomials here now. The first term from the first binomial is 3x square. Into the second binomial we have to write it as to 2x square minus y square. Now the plus will come down as it is, plus and this entire term 2y square into the second binomial, that is 2x square minus y square. This is now again as 3x square into 2x square plus the monomial 3x square into minus y square plus 2y square into the first term from binomial 2x square plus 2y square into minus y square. Multiply the quotients. 3 into 2 is 6. Base are same x, so adding the parts x power 4. Here plus into minus. So plus into minus, when we multiply two opposite signs, we have to keep minus. So minus 3, and for this minus y square, it means it has 1 as the numerical coefficient. So 3 into 1 is again 3 x square y square. And in this plus 2 into 2 is 4 x square y square. From the last term, again here it is plus into minus, two opposite signs, so minus 2, same base y and y, so adding the powers y power 4. Here if we see we have like terms, so we can simplify it further. 6x power 4, one is minus term and the other one is plus term, so just subtract the things and use the sign of the larger numerical quotient. So here 4 is the larger one, plus 4 minus 3, that is 1. We don't have to mention 1. X square y square minus the last term 2y power 4. Now whatever we have seen here is again horizontal method only. We'll see into the vertical method as well. For that we have to write down the polynomials one below other. 2x plus 3y into 3x minus 2y. Each and every term from this has to be multiplied with the polynomial. First we will take minus 2y and multiply with 3y. Minus 2 into 3 is minus 6y in both the terms. So we have to add the powers, will give y square. After that we have to multiply minus 2 with minus 2y with 2x. So minus 2 into 2 is minus 4. X into y is xy. Once we are done with this minus 2y, we'll look into 3x. 3x into 3y, 9xy. We will leave this term and then we have to write 9xy. This is same as the way we do multiplication for whole numbers. We will leave the last one. So that we have to leave and write the 9xy. After that we have to multiply 3x with 2x, that is 6x square. 6x square, we will write it down as it is. We have to add these two things because they are like terms, xy and xy is there. 9 minus 4 is 5. So 5xy, and this will come as it is minus 6y square. This is how we perform the multiplication in the vertical method. Now we know how to multiply the algebraic expressions. We will see whether the properties of closure, commutative, associative, whether all these properties hold for multiplication of algebraic expressions or not. First thing is the closure property. Closure property states that when we multiply two uh, two numbers or polynomials from a specific set, the resultant should be also be something from the same set. So when we say when we are multiplying two polynomials, the result should be a polynomial itself. Consider two polynomials for this, that is 6x is one polynomial and minus 2xy is the second one. Now we are multiplying these two polynomials. 6 into 2 is minus 12, then x into x is x square y. So this resultant value is also a polynomial. It belongs to the same set as the initial values that we have taken, which means that closure property holds good for multiplication of algebraic expressions. Now, for the commutative property says that the swapping of the polynomials shouldn't affect the result. Initially, we will take two polynomials, say 2x into minus 5xy cube. Once, if we perform this particular multiplication operation, the result should be same even when we swap the position of the polynomials. Let us do this. 2 into minus 5 is minus 10. X into x is x square y cube. Now swap the positions of both the polynomials. Means first we will take 5xy cube into 2x. Here minus 5 into 2 is again minus 10. X into x is x square and y cube. If we look into the results, in the first case and second case both are same, which means the swapping of the polynomials didn't affect the result. That is why multiplication of algebraic expressions is commutative. The next is associative property. Associative property says that when we rearrange the parentheses in any operation, the result should not be affected. If it didn't get effects, then the property holds good. Take three polynomials for this, like 2x square and minus 3yz, and other be like 5y cube These are three different monomials here, and we want to multiply all these things. For that, we have to initially perform multiplication on two polynomials, the result of which has to be multiplied with the third polynomial. Initially, we will consider these two polynomials. 2 into minus 3 is minus 6, x square as it is, and yz. This result has to be multiplied with the third polynomial, that is 5y cube. Minus 6 into 5 is minus 30, x square as it is, and y also goes like y is that we have y power 1 here and y cube. Add the powers, 1 plus 3 is 4 and z. Now again we will perform the same multiplication, but in this case we will rearrange the parentheses into 5y cube. Now what we will do is we will multiply the last two polynomials first. So minus 3 into 5 is minus 15. Y into y cube is y power 4 z. And now the first polynomial is 2x square. When we perform this operation, 2 into minus 15 it is minus 30. X square as it is y power 4 and z. Now if we look at these results in the first case and the second case, the polynomials are same, but we have rearranged the parentheses. Both are leading to the same result. So multiplication of algebraic expressions is associative. After that we have distribution property over addition. So which we would have learned like a into b plus c is equal to ab plus ac. We have to see whether this is applicable for algebraic expressions or not. For that, let us take different polynomials like 2a is a monomial, and then we have b square is another monomial, and c is a third monomial. What we have to do, this is first, second and third, multiplication over addition. So this should be equal to 2a into b square plus 2a into c. We don't know whether this is true or not. For that, what we have to do is we will substitute some values for a, b and c, and we'll see whether this equation satisfies or not. Let us take a is equal to 2 here, then b is equal to 4, c equal to minus 1. From the left hand side, we'll substitute the values. 2 into a is 2, brackets open. In place of b, we have to write 4 square, plus in place of c, it is minus 1. 2 into 2 is 4, 4 square is 16, plus of minus means minus 1. 4 into 16 minus 1 is 15. So 4 into 15 is 60. This is the left hand side of this equation. Now coming to the right hand side of the equation, again substituting the values. 2 into, in place of a, 2, and in place of b it's 4 square, plus 2 into again a is 2 and c is minus 1. So here 2 2s are 4. 4 into 4 square, that is 4 cube, which is nothing but 64, plus 2 into 2 is 4. 4 into minus 1 is minus 4. So this is 64 minus 4, that is 60. Here we can see the left hand side and right hand side, the values are same after substitution, which means the multiplication of algebraic expressions is also distributive over addition. A distributive property over subtraction, which means that when we have A into B minus C. This would be equal to AB minus AC. For this also, let us take another example, like consider 2x as one monomial, then 3x and minus 2y as a last monomial. If we arrange these values in that a into b minus c, it would be like 2x into 3x. We'll, like, we'll take this as 2y, okay? Minus 2y equal to a into b, that is 2x into 3x minus 2x into 2y. This is nothing but we will have 6x square minus 4xy. We'll see whether this is correct or not by substituting some values for x and y. Let us take that x is equal to 2 and y is equal to 8. From left hand side, we will start to solve this. In the left hand side, if we substitute the values, 2 into x value is again 2, 3 into x is again 2, minus 2 into y value is 8. So 2 into 2 is 4, 3 into 2 is 6, minus 2 into 8 is 16. So 4 into 6 minus 16 is minus 10. So this will give minus 40 as the value. Now if we do from this right hand side, substitution of the values gives 6 into 2 square minus 4 into 2 into, in place of y it's 8. 2 square is 4, 6 into 4 is 24, minus 4 into 2 is 8, 8 into 8 is 64. 24 minus 64 is minus 40. If we compare these results, left hand it is minus 40, right hand also it is minus 40, which means that distribution property over subtraction is also applicable for the algebraic expressions. So in this video, we have covered how to multiply two monomials, a monomial with a binomial, two binomials, and we also checked whether the properties of closure, commutative, associative, and distributive are applicable for algebraic expressions or not.